From today onward, I will spend a lifetime telling the internet about the cosmos. Even if for now only a few signals are listening, and if one day this channel gathers millions of people who still look up at the stars with wonder, then that will become a cosmic romance created by both you and me. When I was younger, I used to believe the universe was probably crowded, not because I had proof, but because the night sky looked too large to be empty. I remember sitting outside with a small telescope, trying to find Jupiter's moons, and thinking that somewhere out there, another civilization might be doing the same thing. Another mind, another sky, another small creature staring upward, wondering if anyone else was alive. That thought felt comforting, but the older I got, and the more astronomy I studied, the more uncomfortable the silence became. Because if planets are common, if stars are everywhere, if the chemistry of life is not unique to Earth, then why does the universe still feel so empty? Tonight we explore one of the most disturbing ideas in the search for alien civilizations, the Great Filter. NASA's exoplanet discoveries should make us optimistic at first. The official number of confirmed planets outside our solar system has passed 6,000, with thousands more candidates still waiting to be confirmed. Think about that. 6,000 worlds, not stars, worlds. Places with gravity, skies, atmospheres, storms, heat, ice, darkness, and maybe oceans. And that number is only what we have confirmed so far. It suggests that planets are not rare. They are not cosmic accidents. They are everywhere. Some of them even orbit inside what NASA calls the habitable zone, the distance from a star where liquid water could exist on a planet's surface. And when I first learned that, I remember feeling a kind of childish excitement, because water feels like hope. A rocky planet in the habitable zone feels like a beginning. It feels like the universe is quietly saying, here, maybe life could happen here. But this is where the real science becomes less romantic. A habitable zone is not a promise, it is only a possibility. A planet can sit in the perfect orbit and still be dead. It might have no atmosphere, or too much atmosphere. It might be blasted by radiation from its star. It might be tidally locked, with one side burning forever and the other frozen in endless night. It might have water, but no chemistry capable of becoming life. It might have life, but only simple life. No forests, no animals, no cities, no radio signals, just oceans full of microbes under an alien sun. This is the first lesson of the Great Filter. Every step is harder than it looks. The Great Filter is a possible answer to the Fermi Paradox. The paradox is simple. The galaxy is old. The galaxy is huge. The galaxy contains billions of planets. So if life can become intelligent, and intelligent life can become technological, and technological civilizations can spread into space, then someone should have filled the Milky Way long before humans appeared. We should see evidence, signals, probes, megastructures, artificial lights on distant worlds, something. But so far we have not found clear evidence of another technological civilization. Only silence. The Great Filter suggests that somewhere between lifeless matter and a star-faring civilization, there is a step so difficult that almost nobody gets through. A wall, a trap, a test that most life fails. And the most terrifying question is this: is the filter behind us, or is it still ahead? If the filter is behind us, then humanity may be incredibly rare. Maybe the origin of life itself is almost impossible. NASA's exobiology program studies questions like the origin, evolution, distribution, and future of life in the universe. That sounds simple until you really think about it. We still do not fully understand how non-living chemistry became living cells on Earth. At some point, atoms became molecules. Molecules became systems. Systems became something that could copy itself, evolve, and survive. That transition may be one of the hardest events in the universe. Maybe most planets never cross it. They have oceans, they have lightning, they have minerals, they have time, but no life, no first cell, no evolution, no creature ever looking up. Or maybe simple life is common, but complex life is rare. For most of Earth's history, life was microscopic. For billions of years, Earth was alive, but not intelligent. There were no telescopes, no spacecraft, no questions about the stars, just cells surviving in water, stone, heat, and darkness. That matters. Because when we imagine alien life, we often imagine cities, machines, languages, and civilizations. But the universe may be full of living worlds that never become aware of themselves. Planets where life exists, but never builds anything, never sends a signal, never asks whether it is alone. And then there is intelligence. This one bothers me personally. Because humans like to think intelligence is the natural goal of evolution. But evolution does not have a goal. It does not try to build scientists. It does not try to build rockets. It only rewards whatever survives long enough to reproduce. A planet could be full of life for hundreds of millions of years and never produce a species that studies the sky. Intelligence may not be destiny. It may be an accident. And technology may be an even stranger accident. You need fire, language, memory, tools, social cooperation, stable climate, energy sources, curiosity, and enough time without being erased by disaster. When you stack all of those steps together, the silence starts to feel less impossible. Maybe the universe is not empty because life never begins. Maybe it is empty because life almost never climbs the entire staircase. But there is another possibility, and it is much darker. Maybe the great filter is not behind us. Maybe it is waiting in front of us. Maybe many civilizations reach our stage. They discover electricity, they split the atom, they build computers, they map their genomes, they alter their climate, they create artificial intelligence. They become powerful enough to reshape their world before they become wise enough to protect it. And then they fail. This is the version of the great filter that keeps me awake at night, because it does not require a black hole. It does not require a gamma ray burst. It does not require an alien invasion. It only requires a civilization to become too powerful too quickly. A species can survive predators, it can survive ice ages, it can survive famine. But can it survive itself? That may be the real test. NASA's search for life is becoming more advanced every year. Future missions are designed to study distant worlds more directly, to search for atmospheres, chemistry, and possible biosignatures. But even this is extremely difficult. NASA has pointed out that an Earth-like planet beside a Sun-like star would be almost invisible because the star's light would overwhelm it. From far away, even Earth would be hard to see. That detail has always stayed with me, because it means silence is complicated. Maybe the galaxy is full of life and we simply cannot detect it yet. Maybe alien civilizations are too far away. Maybe their signals are too weak. Maybe they communicate in ways we do not understand. The silence does not prove we are alone, but it does force us to ask a more uncomfortable question. If life is common, why has no one become obvious? Why has no civilization changed the galaxy so much that we cannot miss it? The Great Filter is terrifying because it turns the search for aliens into a mirror. Every time we fail to find another civilization, we are not just learning about space. We are learning something about ourselves. Maybe we are early, maybe we are rare, maybe we are lucky, or maybe we are approaching the same test that destroyed everyone else. Personally, I do not think the scariest version of the Great Filter is that life is impossible. The scariest version is that civilizations like ours are common. They rise, they discover science, they look into the night sky, they ask the same questions, and then, somewhere between becoming intelligent and becoming truly wise, they disappear. So here is the question I want to leave with you. If the Great Filter is ahead of us, what should humanity do? Should we spread into space as fast as possible, even if we bring our problems with us? Or should we slow down, become wiser, and learn how to survive on one planet before trying to claim another? Some people believe reaching the stars is humanity's destiny. Others believe that a species unable to care for Earth has no right to export itself into the cosmos. I want to know which side you are on. Is space colonization our survival plan? Or is it just our arrogance wearing a spacesuit? Comment below. Because if the Great Filter is real, The most important question may not be where the aliens are. It may be whether humanity is already standing at the edge of the same silence.